solve really from your calculator. You just have to understand a few things about power functions. So we're going to do functions defined by roots and by powers. Your power function is written in the form of f of x equals x, and they say to the b. That's not a 6, that's a b. F of x equals x to a power. X to a power is a power function. Okay, a root function would be f of x equals x to the p over q, which can be written as the q root of x to the p, which can also be written as the q root of x and then raised to a p. These are all the same thing. This is a root function. Okay, so when you see fractions as exponents, what they mean is roots. They're either like a square root or a cube root or a fourth root or a fifth root. Your denominator is the index, that's called the index of the root. Okay, so whatever your denominator is the index of the root. So for example, this says rewrite with positive rational exponents. Rewrite this with a positive fractional exponent. Well, in a square root, if you didn't know this, there is an understood 2 right there. That's the index for square. For the exponent of x, there's an understood 1. So this is really x to the 1 over 2, 1/2. So then what would this be? The 8th root of x squared. Well, that would be x to the 2 over 8, which is really what? X to the 1/4. Easy peasy. And then they go from those two to like something really crazy looking like this, but it's not hard, no fear. This is a square root. So there's an understood 2 right here. This y is by itself, so it has a 1. And then this is a fourth root of y to a 1. So we're going to start here. We're going to start at the innermost part, and we'll work our way out. This is really y to the 1/4. The 4 is on the bottom. And you're multiplying it by y to the 1. Well, if you know your rules about multiplication, anytime you're multiplying like bases, you keep the base and you add the exponents. 1 plus a fourth is 1 1/4 or 5/4. And then don't forget, this is still under a square root. So that would mean y to the 5/4. You can even think like this, divided by 2. I know that seems crazy, but that's what you're doing, because whatever your index is what you're dividing by. And 5/4 divided by 2, again, you can use your calculator for that. This is really all calculator based. You put it in a parenthesis. 5/4 divided by 2 is 0.625. You can hit math, frac, and enter again 5/8. So this is really y to the 5/8. Very easy. All right, then you get to evaluate. Yay! Evaluate means just plug it in your calculator. So 16 to the 3/4. Again, you can let your calculator do all the work. It will give you an 8, but just to show you what it's doing, because I know there's people that want to know. This is really the 4th root of 16, and then you cube it. And the 4th root of 16 is 2, and 2 cubed is 8. So same thing here. You can literally punch this into your calculator. Negative, and I'll put parentheses, negative 125 to the power of 2 divided by 3. And you get 25. But here's again, just what you're doing. That cube on the bottom, that, that third is really the cube root of negative 125. And then it's squared. And the cube root of negative 125 is negative 5. Negative 5 squared is 25. And so on and so on. So this one, now this is 216 to the negative 5/3. So now this one is going to be not a pretty one. I'll tell you that right here. Just to show you, to the negative 5/3. Yeah, you get this E, you get this scientific notation. Even if you try to hit math frac, I don't believe it'll give it to you. Oh, it does. Never mind. I lied. 1/7776. Okay. But let me show you again how that happens. So this would be the cube root. Actually, let me take that back. That negative means that it's actually should be written as 1/216 to the positive 5/3. You got to move it down. And now that would be the cube root of 216 to the 5th power. And the cube root of 216 is 6. So this is 1/6 to the 5th, and 6 to the 5th is that. All right, and then now this one, the 5th root of negative 243. Again, you could, how could you type this into your calculator if you don't know where there's a 5th root? You can just type negative 243. 5th root means to the 1/5 power. Negative 3. I mean, that's really what that means. Negative 243 to the 1/5. That 5 is the denominator. And the 243 it has an exponent of 1. So this would just be negative 3. So easy peasy. Again, all stuff done in your calculator. Woohoo. All right, now let's talk about root function when n is even, as opposed to a root function graphically when n is odd. So just so you know, you probably remember this, like think about what a square root function is. Like if f of x was the square root of x, or x to the 1/2, or the 4th root, what would that look like? So it just looks like it starts here and it kind of like shoots over. It shoots over and up. And so your domain would be from 0 to infinity. That's how wide it's getting. Your range would be the same, 0 to infinity. That's your even power one. So square root, 4th root, and x to the 1/6, 6th root, something like that. It definitely looks, they all look the same. If n was odd though, so like let's say this was a cube root. So f of x equals the cube root of x, which is x to the 1/3. So this one looks like this. Okay, it doesn't have an asymptote. It does keep curving upward ever so slightly. Okay, and you can check it out in a calculator and type it in. But in terms of domain and range, this domain, how wide is this thing getting? It's going from negative infinity to infinity. The range, again, it looks like it's leveling, but it's not. It's going to keep creeping ever so slightly. So it's going to cover the entire range. It's going to go from negative infinity to infinity. And you need to know that for the next questions on this section. Look, we're on our last page. Woohoo! And I thought we would be going till 8:30, so I'm impressed. So the next questions will say this. They'll say, find the domain of each. Where's the function increasing, decreasing, and what is the solution? Oh, there it is again. Where's the solution to f of x equals 0? They love this. I'm going to highlight that. Okay. So you can plug this into Desmos. And again, I want to show you both ways because there's a lot of people who are visual learners. And so They don't have, they have square roots, let's see, but I'm gonna make it go to the 1/2 power, just so you can see, even in Desmos. There it is. So there's your square root function. And if I asked you what the domain is, you look at this point right here. So from -3 to infinity is the domain. And then it asks us questions like, where is it increasing and decreasing? Well, obviously it's increasing from -3 infinity to -3 to infinity, excuse me. Is it decreasing? No, because you start on the left and you move to the right, you're always going up. And then where is the function equal to 0, the x-axis? Well, right there at x equals -3. So let me write this all down for you. Give me a second. There we go. So the function was at 1, 2, 3, -3, and it went over like that. And so if I said, where is it? What's the domain? You would say, whoops, from -3 to infinity. It's increasing. And for increasing, you don't have to write it with brackets. You just have to write it with parentheses. So -infinity to 3. Decreasing, never. It's not decreasing at all because you start from the left to the right. And then the solution to f of x equals 0. That again is just, where is it going to cross this x axis right there that I just highlighted in yellow? And the only point it crosses at is -3. X equals -3. Just so you know, analytically, the way to solve this is under a square root, you just take whatever's underneath it and you set it greater than or equal to 0. And you get 4x is greater than or equal to, whoops, -12. So x is greater than or equal to -3, which is what that's domain is saying right there. So it's an analytical way of doing it. Okay. Let's look at this odd root. The ninth root of 4x plus 1. The ninth root of 4x plus 1. Again, I go to my good old buddy Desmos. Desmos doesn't have a ninth root, so you have to know how to type it in correctly. 4x plus 1, you have to, too many parentheses, raise it to a power of 1/9. And so now look at there. Again, it looks like it's leveling off, but it really isn't. I mean, if you keep going, it's gonna, surprisingly enough, it's gonna cover the entire range and it's gonna cover the entire domain. And that's because it's an odd root. Okay. So back to my sheet here, just so you know what I did. Okay, so this is an odd root. And the way I type it into Desmos is 4x plus 1 to the 1/9, or into a calculator. Your domain would be from -infinity to infinity. Where is it increasing? Well, again, I should draw it out for me. It kind of looks like it is actually from the left to the right. It's actually increasing the entire time. So it's always increasing along -infinity to infinity. Decreasing, it's not, because again, left to right, it's never decreasing. And then the solution to f of x equals 0. And that we didn't check that out. Let's see on Desmos if I have an x-intercept. Oh, I do. Look at that. The x-intercept is at -1/4. X is -1/4. And again, analytically, you can just set this function equal to 0 and solve it. But, Desmos gives it to you nice and easy. All right, last few things here. We're almost done. Easy breezy. I told you this one was way nicer than that one. Use transformations to explain how the graph of y can be obtained from y equals the square root of x or the cube root of x, depending on which ones they give you, okay? So this isn't actually too hard. You'll see it's stuff that you've done before, but using transformations, meaning does it go up 5, left 2, down 3? So that plus 2, we already know what that means it's going to do. We know it means it's going to shift up 2. Anything on the outside moves up or down. It's the inside right now that is a little bit weird. So we're going to actually write it a little bit differently. When I see something on the inside like 9x plus 36, I want to factor. You just should always have a tendency to want to factor things. So I'm going to rewrite this as take out a 9 and you're left with x plus 4. And now your rules for square roots, if you remember, you can actually break this into a square root of 9 times the square root of x plus 4. And then that plus 2 is on the outside. And the square root of 9 is really just 3. So 3 square root of x plus 4 plus 2. So now I can tell you what the transformations are much easier from the parent function of square root of x as opposed to 9x. So what's my parent function here? Well, this right here on the outside sets that there's a vertical stretch by a factor of 3. This one on the inside of the parent, you go left or right, opposite of what you think. So this is plus 4, so I want to go left 4. And then obviously the plus 2 means I go up 2. And that's all you'll have to do is click. But you have to rewrite this in that form just to make it more understandable on Pearson. Let's do another one like that. So again, part B says, or part B example is y equals the cube root of 8x plus 16 and then minus 5. So underneath that radical, I want to factor it. I want to take out an 8 and I'm left with x plus 2. And then I can break this into the cube root of 8 times the cube root of x plus 2. And the cube root of 8 is 2. So 2 times the cube root of x plus 2 minus 5 is what y is actually equal to. And now I'm just going to, again, explain what each one of these represent. This is the vertical stretch. Any number on the outside is your vertical stretch. On the inside, it's left and right, depending on what they give you. So this is left 2, minus 5, down 5. And that's literally what you'll have to click on Pearson. All right, last two. Woohoo, squeezing it in. Equation of a circle with a center at origin. So a little bit more geometry things that maybe you haven't seen before. If you are drawing a circle on a coordinate grid, the equation for it is x squared plus y squared equals r squared, where r is your radius. So if I had something like x squared plus y squared equals 4, I would have a circle that goes like this. You go over 2, up 2, left 2, down 2. And that's your circle. Now, if you want to put this in a calculator, you actually have to solve for y. So you would have like y squared equals r squared minus x squared, and then take a square root. And you have y equals plus or minus. So you have two things. You have the square root of r squared minus x squared. And then you have y equals negative the square root of r squared minus x squared. And that's how you'd have to put this into y1 and this into y2. I will tell you though, Desmos doesn't even need you to do that. you can literally type in x squared plus y squared, just like it is. And then just to show you, you can do x squared plus y squared. And I'll do equals 4 again. And it just draws a beautiful circle. But in the calculator, you actually have to, because calculator only does y equals. So this is very, very, very nice. It gives you all the nice little coordinates right here. But the reason why I showed you that was because of this next example right here, because it says, okay, find the domain of f of x equals the square root of 121 minus x squared. And what I noticed was this is really 121 is actually a square root. The square root of 121 is 11. This right here is in this form right there. And so what you have, I mean, you can put it in Desmos, but really what you have is a semicircle. You have this positive root as opposed to the negative, which is the reflection. So you have a semicircle, and that right there is your radius squared. So you have a radius of 11. And so I already know that I'm going to have just half a circle. I'm going to have from negative 11, this one's positive 11, this one's positive 11, and I just have half a circle. And again, you can put that right into Desmos as is. You can type, square root of 121 minus x squared, and you'll see that picture right there. And then if I asked you what's the domain, it does hit the x-axis. So the domain is from negative 11 up to 11. And that's how easy that question is. But again, very Desmos related. So much easier 5.4 section, really just about rational expressions, power roots, and whatnot. And